Hi, I'm Rodrigo Marquez with Pi Energy. We are a company doing lightweight and flexible solar cells with advanced materials and nanotechnology. So, a quick story about what's the most talked about point about solar is that prices have come down in a very steep manner. And that's been going on for quite a while. And the reason is clear. There has been a massive deployment of capital by China, increasing manufacturing capacity and driving manufacturing costs down in a way that they took over the market and they manufacture 95% of solar panels today in the world. But, and there's an important but, the technology is still the same, roughly as it was 80 years ago. We have a rigid product, it's heavy, and it's also carbon intensive. The weight of it is like 30 kilo per square foot, and the rigidity makes it not viable for certain applications. So they cannot be really used in some areas where there's high demand for it. For example, low weight bearing roofs, or now that mobility is going to be increasingly using electric vehicles, so you can apply it for freight, for trains, for electric buses, and things of the like. And those are markets where traditional solar cannot do anything about. Flexible, lightweight cells would be the answer, but they are also, the solutions that are out there in the market are hampered by several issues. So we have OPV, degrades quickly. Perovskite is unstable, particularly for flexible devices. And then there are others, like cattail, that need to be encapsulated because they're really toxic and built around scarce materials. And the supply chains of those are also complicated. So here we come with Pi Energy. Pi Energy, we have developed this incredible technology. This is how flexible it is, and how thin it is, and how resistant it is. I'm kindly going to ask one of you to just pass this around, and please remember to give it back to me when I'm off the stage. So basically, it's a very lightweight material. It's also a very low carbon footprint, and it would work perfectly for this type of applications that I'm talking about. The weight per kilo is like less or 1 kilo per square meter, as opposed to 30 kilo for traditional solar. And also, we can offset with our manufacturing process the carbon emissions of these things in less than a month, as opposed to 4 years for traditional crystalline silicon panels. It's a proprietary technology, and we have the patents in the field. So this is it basically working, and I couldn't put a video there, but you can see how it makes a fun turnaround. The applications for low weight bearing roofs is absolutely obvious, and it's something that I would like you to go out of this pitch with the idea of thinking about your kids going to school. So they would take a bus. So imagine that they would take an electric bus which would have no emissions, and therefore there would be no fumes and stuff that could harm them. But imagine also that with this material, we can actually cover that bus, which would actually be self-charging while parked or while it's driving. And that's a wonderful way to send kids to school for solve future problems. The efficiency of what you have in there is slightly under 10%, and we can bring that to an efficiency of nearly 20%. Which would make it really competitive with existing solutions out there in the market. So our fabrication process, it's low cost, and it has minimal energy requirements. And the reason is that it's a wafer-less type cell. We do not have to use high temperatures to do what we do. We can do it at low temperatures. We can manufacture that using off-the-shelf existing equipment for other industrial applications. And it's an additive fabrication process. Which brings us to supply chain issues. And this is a hot topic at the moment, particularly because of all the trade wars, all the bottlenecks that we have seen, all the difficulties with supply chains being controlled by China. If we produce these, whether in the US or Europe, we wouldn't have any supply chain issues for all of the process of setting this up. The other thing that's important for you is that particularly Article 9 funds. These are the way, this shows the emissions that would be offset by our technology compared to traditional solar. And you can see very quickly that at scale, there can be gigatons of emissions avoided over time. So the applications are for low weight bearing roofs. We do not want to be competing head on with traditional crystalline silicon market. So we would go to the places where they cannot be deployed. Just in Europe, in warehouses, there's more than 150 gigawatts of potential for capacity. That's several nuclear plants. And that's a market that's there for the taking for us. Transportation-wise, we can extend the daily range of a fleet of vans covered by our material or wrapped by our material by probably 15% a day, which would make savings for the fleet owners and would eliminate range anxiety to many owners of electric vehicles. So our business model is a hybrid of licensing fees. We're basically an R&D company with proprietary technology, and also we'll partner up in JVs, particularly for the purposes of the IRA in the US, and to take advantage of that framework, which is extremely helpful to us. And we have the right team put in place for that. We just hired a CEO who was the CEO of Sempra Renewables, a large utility based in the San Diego area. And we have also very bright people in our team that have worked on space probes and things of the like, and contractor for NASA. And we are, at the moment, trying to attract VCs into our rosters. For the most part, our investors have been high net worth individuals and family offices, and we want to attract VCs by the use of a SAFE, which is a vehicle that avoids us to have these difficult discussions about valuation, and it's very flexible for this. So thank you very much.